Hey guys, we are the Null Operators, and this is video number 6 in our Learn to Code with Java web series. Today we're going to be covering multidimensional arrays. So in a previous video, we went over one-dimensional arrays, and you can think about one-dimensional arrays as a series of values. So this would be a one-dimensional array. Well, today we're going to be talking about multidimensional arrays, where we add on to this concept. So if a one-dimensional array is a series of values with these index values, if we expanded that to a two-dimensional array, we would basically have the same thing, except that for each one of these index values, that index would contain another subarray. So this right here is all contained inside of index 0 for this array, and so on and so forth. Index 1 of this array has another array of size 4. Index 2 has another array of size 4. And we can continue this concept outward with something like a three-dimensional array, where I would have, no, don't need that 0, but I would have a one-dimensional array. Each index of that one-dimensional array would have its own array, and each index of this array would have its own array. So it's kind of written a little bit nastily, but you can kind of imagine it as a cube, right? So it has a length, it has a width, and it also has a height. And we can continue expanding this to 4 dimensions, 5 dimensions, just keeping in mind this idea right here. So if it was 4 dimensions, each one of these would have its own subarray. 5 dimensions, each one of these would have its own subarray. So this will make a little bit more sense whenever we actually go look at it in code. So first things first, how do we actually declare a two-dimensional array, or a multi-dimensional array rather? So first we're going to need our data type just like a one-dimensional array. We'll do a one-dimensional array example. So we had integer array equals a new integer array of size 10 or something like that, right? So a two-dimensional array declaration is going to be pretty similar. We add another set of square brackets and we give it a second size. So we could declare it this way, where I say create a new array. It's got 10 rows, 5 columns, or we could just create it and leave it uninitialized, or we could create it and just pass in the values manually, similar to how we did with a 1D array. But the one thing to remember is that whenever we're passing in these values manually, since it's two-dimensional, we have the pair of curly braces on the outside at the beginning and the end, right? So this curly brace and this curly brace represent the entire array, and then these represent each subarray inside of that entire array. So I would have like 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And if I wanted to display this array or do something with this array, right? We know that we used for loops with our 1D array, and we're going to do the same thing with our two-dimensional array, except we can't do it with just one for loop. We need a nested for loop. So nesting just means that this thing is contained inside of the other one. So if we go and do the for loop that we're accustomed to before, we'll do array3.length, I++, nice and easy, same as before. But the inner one's a little bit different. So I can't just say array3.length here, like I did above, because this .length attribute is referring to the length of the first dimension, but we're dealing with 2 dimensions here. So in order to get the length of the second dimension, I would say array3 at index I.length. Because if you remember, each box in this array, since it's two-dimensional, each index has its own subarray. So I'm saying get the subarray from array3 at I, get the length of that subarray. So we'll print out the value for those elements. And you'll notice that I include both both dimensions here. So I have I for the row and j for the column. And I'll include a space. And I'll create a new line after each row. Let's see how this looks. So I get all these values that I entered up here, I'm going to get them displayed down below. So the inner loop is the one that's saying inside of this row, right? We're at row 0, the first row. It's saying go through and print out every value in that row. And then after that's done, create a new line and move on to the next row. So it's pretty similar to what we did with 1D arrays. There's just an extra layer. There's this extra for loop inside. And we need to make sure we remember, one, that the length of this is not going to be the length that we used before, but the array at I.length instead of just array.length. And then whenever we print out the value, we need to make sure to include both dimensions because this is a 2D array, right? And something interesting that you can do is, here we have a 3x3 array, right? We can actually make what's called a jagged array. So say I took off some of these values and I have, let's say, 1, 3, 4, 7, 8, 9. So we can have different numbers of columns in this array based on the row. So row 0 here would have 2 columns. Row 1 would only have 1 column. Row 2 would have 3 columns. And since we're using this array3 at I.length, it gets the size of this array no matter what size it is and prints out the values. So I would get 2 for the first, 1 for that, 3 for the third. And we can prove that just by running this. So this is what's called a jagged array. Usually you won't have to deal with these, but it's good to know that they exist. So if we go back to our previous example, what would we do if we made a 3D array here? So let's try that. Let's say there's a new integer array. And I'll just say that this is size 5 by 3 by 2. So we'll do the same thing. I'm going to go for I, 0 to array's length, and I'm going to do the same thing, j from 0 to array at I.length, and then I'll need another for loop because this is 3 dimensions, right? And inside of here, I'll create another variable, int k, and then here, we'll need to specify array at ij.length. So I need to get the size of the subarray from the specific box that I'm looking at. So instead of being array.length or array at I.length, now it's array at ij.length. I'll do k++. And here we'll just fill it with some values. I'll just say array at ijk, we need all 3 dimensions, is going to equal, we'll just say k. And we'll also print it out. And then we'll create a new line. After up, we need Control C. There we go, there we go. So whenever we run this now, we'll see that we have 2 values on each layer, right? So this last dimension was 2, so I get a 0, 1, 0, 1, 0, 1. I get that 3 times because the second dimension is 3, and then I get this 2 by 3 5 total times because the first dimension is 5. So it's a little hard to wrap your head around whenever you're moving past 3 dimensions because we don't have a 3D representation of this. It's a 2D representation, like visually. But if you can wrap your head around it, it'll allow you to make 4-dimensional arrays, 5-dimensional arrays, which may have some use for you. But let's dial it back. Let's go back to our 2D arrays, and let's look at some application for that, right? So I'll just give it some manual values here, and I'll say we give it a 1, 2, 3, a 4, 5, 6, and a 7, 8, 9. And I forgot to mention before, make sure that whenever you're given it manual values, that you separate these with commas, right? So the things inside of the curly braces are separated by commas, as well as the groups of curly braces have a comma after them. But so we filled that. Let's create our for loop. And we'll do our standard here that we're used to. And then one more time, we'll create j. We'll make sure that j is less than array.i.length, because I want the length of the subarray. So inside of here, let's say that I wanted to get the sum for all the rows, right? So this for loop, if we can imagine it, right, we have a grid. We're going one row at a time, right? So we're going vertically one at a time, and for each one of those, we're going left to right inside of this interior for loop to get all of the columns in that row. So it's going to take me through all of these, and then it'll move down to this, and take me through all of these, and then it'll move down to this, take me through all of these. So that means that inside of this interior for loop, I basically need to calculate the sum for that row, and then after the for loop, I need to reset it, right? Or between those for loops, rather. So I'll create a sum here. I'll set it equal to 0, and this will do the job of resetting it, right? So as soon as I go through this and I go back up here, sum will go back to 0 because it's getting reinitialized to 0. So inside of here, all I have to do is add the current element that I'm looking at to my sum. And then let's say after that, we just print out whatever that sum is. So we can say sum for row, that's too many spaces, row I is plus that sum. So if we run this, we'll say, we'll see that sum for row 0 is 6, 1 plus 2 is 3, plus 3 is 6, that's correct. Sum for row 1 is 15, 4 plus 5 is 9, plus 6 is 15, correct. Sum for row 2 is 24, it's going to be 15 plus 9, 24, exactly. So let's switch it up. Say instead of trying to add up all the values for a row, we wanted to add up all the values for a column. If we think about it, whenever we were adding up all the values for a row, our outer for loop was taking us slowly from row to row, right? And then the inner for loop was taking us through all the columns in that row. Now we want to do it backwards. I want to say for each column, I want to move through the rows and add up the values, right? So we'll say, we'll start off our variable I, and we want that I to be less than the column length, right? And we know that the column length is the one that has array at something dot length. But before, since this was on the inner loop, we could reference I from the outside. Now we're on the outer loop and we don't have something to look at. So what we can use instead is 0. So this won't work for a jagged array, but for a square array, one that has each column has the same number of rows, we can use this. So that'll move us through our columns. We want to create our sum variable and reset it to 0. And we want to move through our rows for each column. So here, our row length is just going to be array.length. So remember, row is array.length, column is array@0.length, or array@i.length. And we want to say our sum is going to get the value of array at row, which row is now represented by j. So we get j, column, where column is represented by I. So not only did we swap which length we were looking at on the for loop, but we also swapped which order the variables go in, because these 2D arrays are always, it's always row column, right? So I'm always going to give the row first and then the column no matter what. So whatever represents your row goes in the first slot, whatever represents your column goes in the second slot. So since our row is represented by j, we pass that here, and our I represents column, so we pass that there. And now we can print out our sum again, or say sum for column, and columns represented by I, so I is sum. So if we run this, we'll see that column 0 is 12, so 1 plus 4 is 5, plus 7 is 12. Column 1 is 15, so 2 plus 5 is 7, plus 8 is 15. And then column 2 is 18, so 3 plus 6 is 9, plus 9 is 18. So we know that this is working correctly. So just try and get creative with how you're practicing with these, because the best way to understand how these things work behind the scenes is to kind of visualize it in your head with this, right? So if I want to move through to add up all the values in my row, I would make row the outer for loop, and I would make column the inner for loop. But if you're doing what we're doing here, where I want to add up the value for all my columns, then I would make column the outer for loop, row the inner for loop, and I just need to make sure that my indexes match whatever is accurate, right? So that'll be it for this video. Let us know if you have any questions or comments. Please remember to hit the bell notification icon, like, subscribe. It helps us out a lot. And we'll see you next week.